Okay, in this part 2 of rational expressions, we're going to look at products and quotients of rational expression. You can see an example of what a product of a rational expression might look like. We're basically taking two rational expressions and multiplying them together. So the steps I have listed there, we want to factor the numerator and denominator, if possible. Could be that there's no factoring to be done. And we do that because we want to cancel common factors or simplify. And we might be able to do that even without factoring. This third step then is we're going to multiply across the numerator and multiply across the denominator. The fourth step and last step then would be to do any simplifying that's possible after we do the multiplication. So let's look at this example. Okay, there's nothing to factor in this one, but we are able to cancel some common factors. If we look at the 30 over 5, there's a factor of 5 that goes into both of those. So 5 into 30 gives us 6. 5 into 5 gives us 1. And now let's look at the y over 5 over the y over, let's look at the y to the 5th over the y to the 3rd. Okay, that y to the 3rd is going to cancel out a y to the 3rd in the y to the 5th. Okay, so we're going to cancel out our y to the thirds on the denominator, and that's going to make it y squared in the numerator. Okay, so let's just rewrite that first rational expression. We've got a 6y squared over x. That's the only thing that's left. In the second rational expression, there's nothing that it is canceling, right? There's no common factors, but we can cancel across the multiplication sign. So if there are common factors in the numerator and denominator across the multiplication sign, we can cancel those as well. So if we look at the 6 and the 21, we see that they both share a factor of 3. So 3 goes into 6 2 times, 3 goes into 21 7 times. And for the y's, we can cancel the y and cancel one of the y's in the numerator. Now, looking at the x in the denominator of the first rational expression, that is going to cancel with one of the x's in the numerator of the other rational expression. And in the denominator, it's going to leave a factor of 1. We've done all the canceling that we can, so now we multiply across the numerator. So we have a 2y times 4x in the numerator. In the denominator, we have a 1 times 7. Okay, so, multiplying where we can, we end up with 8y x over 7. And if you're like me, you're going to want to put the x first, so 8xy over 7. Okay, here's another example. This one where we're going to want to do that first step where we factor the numerators and denominators. So starting with the first rational expression, the numerator, we have a greatest common factor of 6. Bring that out. We're left with x plus 2. In the denominator, our greatest common factor is 3x. That leaves x squared minus 4. And the other rational expression, the numerator is a quadratic with a leading coefficient of 1. So our linear factors are going to have x and x in the leading position. And the numbers that multiply to positive 4 and add to negative 4 are negative 2 and negative 2. So you're going to factor it like that. The denominator has a greatest common factor of 3x, leaving x plus 5. Okay, the denominator of the first rational expression actually can be factored some more. I'm just going to put this here. We've got the difference of 2 squares, so x squared and 2 squared. So we put x in the first position, 2 in the second position, and a plus and a minus. Okay, so that takes the place of what we had before. The 3x stays there, and we've got 3x, x plus 2 times x minus 2. All right, so here's where we want to cancel out. Remember, we can cancel top and bottom across that multiplication as well. We've got an x plus 2 top and bottom here that we can cancel, and an x minus 2 canceling across the multiplication sign. It leaves the other x minus 2, that stays there. Okay, we can also cancel this 3, which leaves a 1, and this 6, which leaves a 2. Okay, I think that's all the canceling we can do. Now we want to multiply across the numerator and across the denominator. So across the numerator, we've got a 2 times x minus 2. Multiplying across the denominator, we've got an x left from the first rational expression, a 3x, and an x plus 5. So if we rewrite that, we've got 2 times x minus 2 over, we can write that as 3, the x times the x gives us an x squared, times x plus 5. Now we're going to look at dividing rational expressions. To divide rational expressions, we actually multiply by the reciprocal. So here's an example where we have this rational expression, 6x cubed minus 24x over 3x squared minus 3, and we're dividing by this other rational expression. So we leave the first rational expression the same, 6x cubed minus 24x over 3x squared minus 3. And we are going to multiply that by the reciprocal of the rational expression we are dividing by. So the x squared minus 2x plus 1 goes in the numerator, and we're dividing by 2x squared plus 4x. Okay, now we just have a multiplication problem. We want to factor. The numerator has the greatest common factor of 6x, leaving x squared minus 4 in parentheses. The denominator has a greatest common factor of 3, leaving x squared minus 1 in parentheses. Okay, the other numerator has a quadratic with leading coefficient of 1, so we're going to have an x and an x for the linear factors, and the numbers that multiply to positive 1 and add to negative 2 are going to be a negative 1 and a negative 1. The denominator has greatest common factor of 2x, leaving x plus 2. Okay, we actually have a little more factoring to do in this first rational expression. So we have a 6x, but we've got the difference of 2 squares. So we want to write x and x, and then 4 is 2 squared, so 2 and 2, and then the difference of 2 squares, so we're going to have a plus and we're going to have a minus. In the numerator, also have the difference of 2 squares, x, and it's 1 and 1, and then a plus and minus. Okay, so that's times x minus 1 times x minus 1 over 2x times x plus 2. Now we get to go through and cancel. And remember, we can cancel across that multiplication. So if we start off, we have a 6 and a 2 in a 6 and a 3 in the denominator. So that 3 goes into that 3 once. It goes into the 6 2 times. And now if we compare that to the 2x in the denominator over in the other rational expression, the 2x will cancel with that 2x, so those go away. Okay, we have got a x plus 2 here and an x plus 2 here, so those will cancel. And we've got an x minus 1 here and an x minus 1 here. So that is everything that will cancel. Let's write down what we have left. So we're going to have equals x minus 2 times x minus 1 over, in the denominators, from the first rational expression, we've got an x plus 1, and we canceled everything out in the other rational expression, so that actually just leaves us with a 1. And so we have x minus 2 times x minus 1 over x plus 1.